So this was a weekly pop quiz related to the MCQs. If you have question or a doubt, you can mention the question. And even having a doubt in question one, question number one. Question 2, 3, 4. Any doubt? Question 2, 3, or 4. Question 5, 6. Any doubt? Any doubt in question 5 or question 6? 5 and 6. What does the D line means? Okay. So in question 5, an object has an initial velocity of u and having an acceleration of a. The object moves in a straight line through a displacement s and has a final velocity of v. The above equation is shown here. This is the equation of the motion in which v square equal u square plus 2as. What condition must be satisfied in order for this equation to apply? Remember, the equations of the motion are applicable if we have a constant acceleration. When we say constant acceleration, it means because acceleration is a vector quantity, so both the magnitude and the direction of acceleration should not change. Magnitude and the direction both should be constant. So the option A, the direction of A is constant and the direction of A is same as the direction of the displacement. No, that is not the rule, because acceleration might be same as the direction of the displacement or it might be opposite to the direction of the displacement. We'll just substitute a negative sign. But so this is not the condition that direction should also be same. It can be opposite. Direction of A should be constant, but it's not a condition that A should be same as the direction of displacement. The direction of A is constant and the direction of A is same as the direction of U. Again, like example, if we launch an object vertically upward, so the direction of a velocity is up, but the direction of the acceleration is down. So it's not a rule. We can apply this equation. It should not have the same direction as the initial velocity or even the final velocity. The magnitude of the A is constant and the direction of A should be constant. So when the magnitude and the direction of the vector quantity is not changing, it means it is constant. Like, what if the object was acceleration of 3 meters per second square towards right, and then it changes the direction and it is 3 meters per second square. So this object, it means there is a change in acceleration. So whenever we apply the equation of the motion, the condition for applying the equation of the motion, the acceleration must be constant. And when we say acceleration must be constant, it means the direction of the acceleration should be constant as well as the magnitude should be constant. Both should be same, should not change. That's why C is the right answer. So direction of acceleration may be equals same as the direction of velocity, may be opposite to direction of velocity, or direction of acceleration may be same as the direction of the final velocity, or may be opposite to the direction of the final velocity, or direction of acceleration may be same as the direction of displacement or opposite to direction of displacement, but these are not the condition. The condition to apply the equation of motion, that A must be constant. And how A can be constant? If its direction and the magnitude both are not changing. Is it clear? Question 6, question 5. So equation of motion is only valid if acceleration is constant. Now in question 6, a car is traveling at a constant velocity. Its brakes are applied, causing a uniform deceleration. Look, if we were having a velocity time graph, then what should be the shape of the graph? This will be the constant speed, because they mention a constant velocity, and then the constant deceleration or a uniform deceleration. So it will point like this. If it was a velocity time graph, but this is not the velocity time graph. In the options, we have velocity and displacement graphs. So if we have a velocity and displacement graph, how to recognize what happened? First, you have to understand like the relation between the velocity and the displacement. To understand the relation between the velocity and the displacement, you have to write equations of the motion. So what are the equations of the motion? Like we have one of the equation is v square is equals to 2as plus u square. One of the equation is s is equals to ut plus half at square. One of the equation is 2 v is equals to u plus at. And the other equation is the last one, s is equals to u plus v divided by 2 multiplied by t. These are the four equations of the motion. Now, because the graph is between the velocity and the displacement, we have to check which equation matches the graph description. So because there is no evidence of the time here in the question, as they did not mention a time, so we cannot use this equation because the time is involved here. We cannot use this equation because even time is not involved, plus there is no displacement. Same thing, we cannot use this equation as the time is not involved as in the question, because the thing which is given, a car is traveling at a constant velocity, so u is given, then brakes are applied and causing a uniform deceleration. So acceleration is there. We want to show how the variation of a displacement with velocity. So time is not involved, so we cannot use these three equations. We can use only this equation. Now, if we use this equation, so v square is equals to u square or 2as plus u square. Now, this is the equation. So, initial velocity is constant. It's not changing. So, means this graph does not depend on the initial velocity. It's not changing. Acceleration is also constant. It is also not changing. 2 is also constant because it's a number. So, means this graph shows that relation between the v squared depends on s. And what kind of relation should be there between the v and s? If we have a graph, so it should be a non-linear relation. When I say a non-linear relation, because if we were having a graph that v is related to the displacement, it like they have the same powers, it means it will be a linear graph. When we say a graph is linear, when we say the graph is a linear graph, it means it must be a straight line. But when there is a power 2 is there or power 3 is there, it means it's a non-linear graph. Non-linear graph means it should be a curve. So the B cannot be a right answer or D cannot be a right answer. Because in B and D, we don't see a curve, it shows a straight lines. But the relation between the V square and the displacement, when the deceleration is constant and the initial velocity is constant, it should be a non-linear graph. So is it clear till this point, the explanation? That's the first part, like how to understand the type of the graph from the equation. So means it must be a non-linear graph. So either A can be an answer or C can be an answer. Because 2 B and D are the straight line graph, means it's a linear graph, which is not possible. What this vertical line at D means, it means the object suddenly stopped. The final velocity, like object was moving at a constant velocity. Even you can understand from the graph that object was moving at a constant velocity and then it suddenly stopped without covering a distance. But in the question, it is a uniform deceleration. So the object changes the speed, gradually changes the speed with a like constant change or decrease in speed. Now, we are left with option A and option C. So first example, object was moving at a constant speed. Just an example, say it was moving at a constant speed of 10 meter per second. So this was 10 meter per second. Then the object decelerate. Example, its deceleration is say 1 meter per second square. So every second it will reduce the speed by 1. So it was 9 meter per second. Then it will be 8 meter per second. First it was 9 meter per second. So in 1 second it will cover a longer distance. Then it become 8 meter per second. So the distance will decrease because the speed is decreasing. Then it travel with 7 meter per second. The distance will also decrease. Then it travel with 6 meter per second. So the distance will decrease. Then it travel with 4 meter per second. The distance further decrease every second. Then it travel with 3 meter per second. And then eventually it will stop. So what will happen if we check option A? First it was moving at a constant speed. Then when there is a decrease in the speed, because it's a constant deceleration, it will cover longer distance. Like when the speed changes from 9 to 10, 10 to 9, as the speed is relatively higher compared to other sections, so it will cover more distance in that time, in unit time. But when the speed is decreasing, the amount of the distance it cover every second will decrease. So which graph shows that this object, when it is moving at a high speed, it cover a greater distance, and that as the speed decreases, it will cover a short distance in every second. So option A shows the right answer. Why not C? Because what is the difference here in C? So this was a speed 10, speed 9. If I equally divide this, so 1, 2, 3, 4, 5, 6, 7, say 8. So when the speed changes from 8 to 7, this much is the distance covered by an object. When the speed changes from 7 to 6, the distance covered by the object from 7 to 6, the distance is less. Then speed changes from 6 to 5, again the distance will be less. But what happened in this graph, say 1, 2, 3, 4 and 5. Say speed was 5 initially. Then when a 5 speed changes to 4, it will cover a greater distance. Why it will cover a greater distance? Because speed is still on the higher side. But when a speed changes from 4 to 3, in every second it will cover a less distance. Then speed changes from 3 to 2, because the speed is less, so the distance covered in a unit time will be smaller. That's why A will be the right answer. Is it clear? Should I repeat? Is it clear? Okay. Question 7. Question 7 and 8, any doubt? Question 7. A ball is thrown across a flat field. Which statement describes the motion of the ball when it effect of the air resistance is ignored? So this object will have the two component as it's a projectile. This will be the initial velocity. It will have the horizontal component and the vertical. This will be the final velocity. That will also have the horizontal component and the vertical component. Look, if we throw a projectile with the, say, the initial velocity of 30 meter per second, the final velocity will also be 30 meter per second if it land on the same level without air resistance and under the influence of the gravity. But we cannot say the ball land with the same velocity. Why we cannot say that? Because velocity is a vector quantity. So even though when we launched, the velocity was 30, the magnitude of the velocity is 30. When it is coming down, the velocity magnitude is also 30. But because the direction has changed, as the direction of the velocity has changed, so we cannot say it's the same velocity. We can say if the statement was there that the ball land with the same speed, then yes, A will be the right answer. But in the question, they mention a velocity. Velocity is a vector quantity. And for a vector quantity, the direction matters. So even though the magnitude of the speed will be same, but because the direction is different, that's why we cannot say it will have the same velocity. It will have a different velocity. So option A, why it is wrong? Because the direction of the velocity is different, even though the magnitude will be same. What about B? The horizontal component of the acceleration is constant throughout the motion. What does it mean? It means the acceleration is not changing horizontally. And that is true because horizontally, what is the acceleration? Acceleration is zero. So throughout the motion, the horizontal acceleration will remain zero. The acceleration will not change. That's why B is the right answer. Why not C? The horizontal and the vertical component of the acceleration are both zero. No, at the highest point, no. The vertical acceleration is always acting downward, which is 9.8, and the horizontal acceleration is always zero without air resistance. So at the highest point, the vertical and the horizontal acceleration are both zero. That is wrong. Why it is wrong? Because vertical acceleration is due to gravity or 9.8 and the horizontal acceleration is zero. And option D, the horizontal and the vertical component of the velocities are both zero. The horizontal and the vertical velocities are not zero. Like when we launch a projectile, it will have a horizontal and vertical component. The horizontal component does not change without air resistance. The vertical will be zero here. Like vertical velocity will be zero, but the horizontal will not change throughout the motion. That's why D is also incorrect. So B is correct, which shows that the component of the acceleration, because means it will have the two acceleration, the horizontal and the vertical components of the acceleration. The vertical component of acceleration will always be constant, which is 9.8, and the horizontal component will also be constant or zero, you can also say, because zero is also a number, which means that it's not changing. So the horizontal acceleration is not changing, which is zero, and throughout the motion, it remains zero. So why D is wrong? Because D is about the vertical component of velocity. The vertical component of the velocity, like example, if you launch a projectile, vertical velocity will be 20, then it will become 10, and here the vertical velocity is 0. And the horizontal component, like example, if horizontal component was 20, so throughout the motion, the horizontal component will remain 20. So the horizontal component is not 0, the vertical is 0 only for the velocity. That's why statement D is incorrect. So when a projectile is launched, remember, like if it is having, say, a horizontal velocity of 10 or say 20, and the vertical velocity is also 20 meter per second. After 1 second, the horizontal will remain 20. The vertical will decrease by 9.8. I'm taking as 10. Then at the maximum height, the horizontal will remain same, but the vertical will be 0. When it is coming down, the horizontal will be 20, then the vertical will be 10. And when just before landing on the same level, the horizontal is not changing and the vertical is also 20 now. So that's why the initial velocity, the magnitude of the initial velocity and the magnitude of the final velocity will be same. But the velocity will not be same because the direction of the initial is different from the direction of the final. So in a projectile motion, the velocity we cannot say it's same, we say speed is same. Question 8, any doubt? Question 8, 9. Question 9. This is related to conservation of the momentum. According to conservation of momentum, the total momentum before must be equals to total momentum after. So what is the total momentum before? This object has a momentum 0 and this object has a momentum mu. So what will be the total momentum before? It will be mu. So when we combine the momentum of these two, we should also get the same result. How we can combine? We can use a vector addition. Any one of them you can draw first. If I draw this as first, so what is the momentum here? Mu by 2, because product of mass and velocity. And what is the angle it is making? This is beta. Then I draw this vector. So when I draw this vector, like because the angle with x-axis is given, so I draw a dotted line which shows an x-axis. And the momentum will be capital M into u by 3. So what is the momentum here? It will be capital M into u by 3. And what is the angle here? The angle here is alpha. And what is the resultant of these two? The resultant of these two will be, because the tail of the first to the head of the last, when we join, we get the resultant. And this resultant will be equivalent to what? The resultant will be equivalent to mu. Why mu? Because according to conservation of the momentum, the total momentum before must be equals to total momentum after. So when I do a vector addition of these two, I can draw this first and the other one second. Like I can draw in this manner, or I can draw this, the capital M first. So if I draw the capital M first, this will be M into u by 3. And the angle with the x-axis is alpha. Then I will draw beta, the second one. And I will draw an x-axis here, and this angle will be beta. And what is the momentum here? The momentum here will be mu by 2. And when I join them from tail of the first to the head of the last, when we join, what we get? We get the resultant. So it will be m into u, because why resultant is mu? Because according to conservation of the momentum, the total momentum before must be equals to total momentum after. So two vector diagrams are possible, either the top one or the bottom one. Now we'll check the options. So we'll check the options, which one it match with. So we have 4 vector diagrams. What is the mistake in A? The mistake in A is the direction of mu. Because mu, as you can see, the direction of mu, its angle is beta. Mu by 2, the angle is beta, but here the angle is given alpha. So that's why A is not correct. Why A is not correct? Because this angle must be beta, but it's written alpha. When we check option C or D, why option C and D are wrong? Because the direction is, B is the right answer, but why C and D are wrong? If you see the direction of mu, what is the direction of mu? According to question, the direction of mu by 2, it is pointing downward, but here it is pointing upward. So means the direction of the vector is not drawn correctly. Same thing, here the direction of the vector is not drawn correctly. Because mu by 2, it should point downward, not upward. So that's why C and D are wrong. So it means B is the right answer. And how B is the right answer? So when mu by 2 we draw, so this is mu by 2 we draw, the angle is beta. Then we draw the second one, this is alpha. So we draw mu by 3. This angle is alpha. And whenever the two parallel lines are like the angle formed, if this angle is alpha, so that this angle will also be alpha. Because when two parallel lines are there, the transversal intersection of the two parallel lines, like if two parallel lines, I cut them by a single line, so the angle formed on the opposite side are congruent. Like example, if this angle was 30, this angle will also be 30. So same thing, If this angle was alpha here, so what will be this angle? This angle will also be alpha because this line is parallel to this line. So if this is alpha, this will also be alpha. And from tail of the first to the head of the last, when we join, we get the resultant of these two vectors. Is it clear, this example? Any doubt in this? Then we have question 10, 11. Any doubt? Question 10 and 11. Question 12, 13, 14. Question 11 and 12. Okay. In question 11, the diagram shows a uniform beam, which is PQ. When we say it's uniform, it means the weight should act at the center. So the weight should act at the center. So if it is a 3 meter in length, the weight should act at 1.5 meter. And its weight is 50. So this is 50 Newton. Whenever you're solving this is in equilibrium. When it is in equilibrium, the clockwise turning effect will be equal to anti-clockwise turning effect. So what is a clockwise turning effect? The clockwise turning effect is 50 into, we always take a distance from the pivot or the point of rotation. So we'll take this 15 to 0.5. Why 0.5? Because the pivot is 1 meter from the end P. So the distance from the pivot is 0.5 for the weight. And this is causing an anti-clockwise turning effect. So weight into the distance from the pivot, which is 1. So we compare the clockwise and anti-clockwise turning effect. So 15 to 0.5, it is W into 1. So 15 to 0.5 is 25. So the weight of this object, it is equals to 1.5. Question 10 as well. The graph which an object is falling freely from a rest in a vacuum. The graph shows a variation. Which graph using same scales to represent the object falling in air? So when object falling in air, it will reach a terminal velocity or its speed will decrease, or it won't reach the same maximum speed at the same time interval. So it should have a lower speed because air resistance opposes the motion. So why not A? Because there is a air. Why not B? Because what B shows that it reaches the same speed at the same. It reaches, like example, at time t, say at time t, the speed was 10. Example. So in this graph, it also shows at time t, the speed is also 10. So which is not possible because in the same time, it will have a lower speed. So it cannot have the same speed because acceleration is not same. Its acceleration is decreasing. So it won't reach the same speed at the same time interval. That's why C is the right answer. So why B is wrong? Because B shows that it reaches the same speed V at time t, but it is not possible because it does not have the same acceleration. So it has a lower acceleration, so it cannot reach the same speed. Why not D? Because whenever object is falling, its acceleration will always decrease, not increase. Because even though the speed is increasing, but the acceleration will decrease. What D is showing, the D shows that the acceleration is increasing, but its acceleration should decrease. Two forces acting each magnitude F at a point V. Two forces form a couple. The shape of an object is a right angle triangle with the sides length X and Y. Which expression gives the torque of a couple? If we need the torque of the couple, means when two forces acting in opposite direction produce a turning effect in the same direction, we call torque of the couple. So if we need the torque of the couple, we need the force and the distance between the forces, the perpendicular distance between the forces. So the force is F. We take only one force, F. And the distance between the forces, what is the perpendicular distance between the forces? That is equals to y. So it will be the torque due to couple will be the force multiplied by the perpendicular distance between the force. So F into y. So B will be the right answer. So we don't take the two forces. It's only a single force. Why not 2F? Because see, when we take a pivot, like example, we take the center of this as a pivot. We take the center of this as a pivot. So this is a force F, which is causing a turning effect F into y by 2, because the distance from the pivot is y by 2. This also force F, and the distance from the pivot is y by 2. Whenever there is a couple, we take the center of the couple, the pivot, the point of rotation, because it's making a perpendicular distance. So we always take a center as the point of the rotation. So when we add, it will be Fy by 2, and this will also be Fy by 2. When we add, it will become Fy. So that's why B is the right answer. So moment due to a couple, we take the force and we take the distance between the two forces. So why we did not take the V or the W as a pivot? Because that is not the perpendicular distance between the force. Like this angle is not 90 degree. This angle is not 90 degree. So whenever there is a couple, we always take the perpendicular distance between the forces. So if I take a pivot here at the center, so this distance will be y by 2 and this distance will also be y by 2. That's why it is f into y by 2 plus f into y by 2. So we got Fy. Question 13, 14, any doubt? In question 13, a giant squid which is having a length of 20 meter in vertically sea water. The top of the squid is at a depth of 8 meter and this is 20 meter. What is the difference in the pressure between the top and the bottom? So what you can do, you can work out the pressure here by using a formula that pressure is density, gravity and depth. You have the density, you have the gravity 9.8 and you have the depth here 8 meter. Then you will find the pressure at this point. How to work out the pressure at this point? Density, gravity and depth. So density is same 1050, gravity is 9.8. And what depth you will take, because the total, this is 8 and this is 20, so the total will be 28 meters. So you can work out the pressure, density, gravity and depth. The first pressure, you will take 8 meter. The second pressure, you will take 28 meters and then take the difference in the pressure, P2 minus P1, that will give you the pressure difference between the 2 points. Or you can also directly take the difference in the height, because look, when I'm doing P2 minus P1, so the first pressure is density, gravity and height 2, the depth 2 I mean, and the second pressure and the first pressure is density, gravity and depth 1. So if I take density and gravity as constant, like common, so it will be H2 minus H1. So if I need the pressure difference, I can just take a difference in the height multiplied by gravity multiplied by density, I'll get the same answer. So either you'd find the pressure at the top and the pressure at the bottom and take the difference to get the pressure difference, or you can just take the difference in the heights and multiply it by the gravity and depth. That will give the same result. Question 14, any doubt? 14, 15, 16. Question 14. In question 14, the diagram shows an aircraft 14, 15, 16, 17. Okay. A diagram shows an aircraft at that instant it was having a velocity of 40. State a rate at which the kinetic energy increase. Look, rate of energy, what does it mean? Rate of energy means power. Any form, because rate of energy, any form of energy, energy in a unit time means power. So we need the power. How to work out the power here? So power is energy divided by time. That is one formula. There's also another formula that power is force into velocity. So at that instant, the velocity was 40. What is the force here? So 500 kilonewton and 200 kilonewton. What is the resultant force here? At that instant, the force was 300 kilonewton. That instant. Velocity will change, yes, because there is a resultant force. So definitely the velocity will change. But for that instant, when the velocity was 40, the resultant force is 300 kilonewton. So what we do, the force is 300 kilonewton, means 300 into 10 to the power 3 multiplied by 40. So when we multiply 3 multiplied by 4, 12, 100 into 10 to the power 3, or it will be 12 into 10 to the power 6. So 12 into 10 to the power 6, we get 12 megawatt. So C will be the right answer. Is it clear, this one? Question 15. A man is running in a straight line. What is the approximate value of a kinetic energy? To work out the kinetic energy, which is half mv square, this is estimation. For example, what could be the estimated mass of a person? Like a normal person, say 60, 70. So I took 70. What could be the approximate speed a person run, like in meter per second? So I guess like 3 meter per second or 4 meter per second. If I just estimate, like in 1 second, I can cover 4 meters or 3 meter. So I'll take like 4 meter. So it will be half into 70 into 4 square 16. So 8 multiplied by 7, which is 56. So 560 joules. So approximately which answer is approximation, like 560, or I will get around 1000, because I just estimate the minimum values. Is it clear? So this is based. Why can it be 100? No, because I selected the minimum values here. Like a person can have a speed more than 4 meter per second, 6 meter per second, and 5 meter per second is average speed of a person. But I took at a lower side. Yeah, 300 meter per second means 3 centimeter per second. Now, when you select, like approximation is done because we select the minimum value. So the approximation, the 560, it is closer to 1000. Like if you have an idea, it's in hundreds. Because if a person is having 100 joule of, if a person is having 100 joule of kinetic energy, it means he should have a mass of a 50 meter per second. Sorry, he should have a mass of 50